Please like, comment, and share. Subscribe to my YouTube channel, okay? So let us talk about X-ray quantum theory. Quantum theory explains the features observed in the continuous spectrum. The features observed in the continuous spectrum. Okay? So we have to assume that the X-ray has a definite minimum wavelength because the electron has a mass m and moves with a speed v on striking the target. Okay, so in this case the energy E is equal to hf according to Maxwell Planck's of the photon is expressed as hf equal to half mv squared, where h is Planck's constant, f is frequency. That is the first case we have to assume. Then we have to look at the work done by the electron of charge E to move from cathode to anode due to the PD applied, that is potential difference applied. So the work done is EV, electron volt, is equal to half mv squared. So we can compare the two, the first case and second case, where we have the energy and the work done. HF is equal to EV, since both are equal to half mv squared, so they are equal to each other. But frequency is speed of light over wavelength. So you substitute that for F, so that we F will be replaced with C over lambda, which is wavelength. Hence, Hc over wavelength equal to EV. Wavelength minimum equal to Hc over EV. Okay, from the formula we'll now notice that voltage increases, then wavelength decreases. Voltage increases, then wavelength decreases. Looking at this question, an X-ray tube operates at 40 kilovolt and the current through it is 5 milliampere. Calculate the electrical power input. Power input is IV, where I is current, V is voltage. The value milli there is 10 raised to the power minus 3, kilo is 10 raised to the power 3. So 5 times 10 raised to the power minus 3 times 40 times 10 raised to the power 3 is equal to 200 watts. You can punch your calculator and the power input is obtained. Then the number of electrons striking the target per second is very simple. It's equal to current divided by charge. And the current is there is 5 times 10 raised to the power minus 3 over charge. Charge is 1.6 times 10 raised to the power minus 19. It's a constant, you must know it. So when you punch your calculator, you get 3.13 times 10 raised to the power 16. 3.13 times 10 raised to the power 16 ampere per coulomb. Then the speed of the electrons when hit the target, half mv squared is equal to electron volt, the work done by electron. Okay, we get the formula from the work done by electron, that's second case. So half mv squared is equal to E volt, making the smaller v is velocity, while the capital V is voltage. So making V squared the simple formula, we have 2EV over M, and M is a constant. M is a constant. 9.1 times 10 raised to the power minus 31 is the mass of electron. Okay? So let's look at the next question. The current through an X-ray tube is 3 milliampere and the accelerating potential is 20 kilovolt. Calculate the number of electrons striking the anode per second. Calculate the speed of the electron on striking the anode. Just like the first one. Number of electron is current all over charge. 3 times 10 raised to the power minus 3 over 1.6 times 10 raised to the power 19 minus 19. 1.6 times 10 raised to the power minus 19 is equal to 1.87 times 10 raised to the power 16 ampere per coulomb. Then the speed of the electron on striking the anode is given as half mv square equal to ev. This is very important formula you need to know. Make v squared the subject formula, just like the previous question. Then 2ev over m, you substitute 2 times charge times voltage over mass. Mass is always 9.1 times 10 raised to the power minus 31. That is the mass of electron. So when you find v squared, the value you get, you punch a calculator, whatever you get, please make sure you are accurate. 7.033 times 10 raised to the power 15. Then to find v, you take the square root of it. Square root of 7.033 times 10 raised to the power 15 is 8.39 times 10 raised to the power 7 meter per second. That is the answer.